Hello and good morning everyone. I welcome you all to India's largest e-learning platform Unacademy, and I welcome you all to GATE Conqueror channel, and I welcome you all to my session of EM Wave Propagation. We are into EM Wave Propagation, and today, along with solving some numericals related to EM Wave Propagation, as a major topic, we'll cover pointing theorem. Just kindly confirm the video and audio once. Yeah. One second here. Yeah. Fine. Thank you. So as a major topic, we are going to cover pointing theorem. Already we had completed EM wave propagation through free space, through materials, through good conductors, good dielectrics, and perfect dielectrics in the previous sessions of the series EM wave propagation. This is lecture number 6 of EM wave propagation. As a major topic, we will cover pointing theorem. Before that, we will also try to do some more numericals related to EM wave propagation. So ask all of your friends to join very soon, dear. This is going to be very important session. Some very wonderful and important problems we are going to do in this particular session. Before we start, let me introduce myself. I am GC Reddy, secured AAR 1931. I work as motivational speaker pan India from the past 12 years. Expert in field theory, which includes electromagnetic theory, antennas and wave propagation, and microwave engineering, and an expert in communication, which includes analog communications, digital communications, and advanced communications. Before we move in, this is the official link, the Telegram link of the GATE Conqueror channel. This is the link here, dear. Try to take a screenshot of the same. Try to take the screenshot. You can join us on Telegram for a personal level assistance from all the GATE Conqueror faculties. Good morning, Anil. How are you? We are into the subject of EMFT. Previously, we are done with module 1. We are done with module 1. Module 1 is elements of EMF theory. In which majorly we had covered static field theory, in static field theory we had covered electrostatics, and magnetostatics. In static field theory, from both electrostatics and magnetostatics, but majorly derived Maxwell equations for static fields, which includes Gauss law, conservative property of electric field, Ampere's law, non-existence of magnetic monopole, or Gauss law for magnetostatics. Then we went for time varying fields. In time varying fields, we discussed concepts like Faraday's law, and Maxwell contribution, and we had modified, and thereby we had modified Maxwell equations for static fields into Maxwell equations for time varying fields. Okay. And besides this, we also covered some important concepts like Poisson's and Laplace equation, and boundary conditions. Very detailed analysis of electromagnetic field theory, which is a complete syllabus for electrical people, is covered, and the playlist is uploaded with a total of 40 videos spanning for 50 hours. I can proudly say that this is most comprehensive series on EMF that you can ever find on YouTube. Just you can go through this particular playlist. This will be useful for covering complete syllabus, all the derivations, all the previous year questions, loads of practice questions, everything into this particular playlist of elements of EMF theory, complete syllabi for electrical and a part of the syllabi for EC. Then for EC, now we are continuing module 2. Module 2 is about EM wave propagation. Now, once these time varying fields are derived, once Maxwell equations for time varying fields are derived, from this we can easily derive the wave equation from Helmholtz equation. From there we can analyze how this wave propagates in different mediums, and we can calculate the power associated with the wave. That is today's major topic, that is Poynting theorem. We can also calculate the polarization, and we can also calculate the reflection coefficient and the transmission coefficient when the wave is incident on a given medium. So all these things, and also we can highlight or understand some important concepts like critical angle, total internal reflection, and Brewster angle. Yes, Surendra, good morning, dear. Okay, is that clear? Fine. Is the audio clear, dear? Fine. That is in EM wave propagation. We are into this module now. After this, we'll go for module 3. Transmission lines. Module 4. Waveguides. Module 5. Antennas. In these antennas, we started this antenna series separately. The name of antennas Mahamarathon. Videos are recorded already here, spanning around 30 to 35 hours. And again I can say that this particular series, Antennas Mahamarathon series, includes everything about antennas. We covered each and every aspect about antennas. It's the most detailed series on antennas so far. 14 videos we have covered, and I'm planning to cover 2 more videos, 15 and 16. Maybe tomorrow and day after tomorrow I'll try to complete this. With this, complete comprehensive series on antennas will also be done. This is already done, and we are into the 6th video here, into the module 2. In couple of days we'll complete EM wave propagation. Once in couple of days EM wave propagation and antennas is completed, we'll start transmission lines and waveguides parallelly. That is 2 different series. Is that clear? ESE electrical. You can go through the playlist, Ravi. Module 1, Elements of EMF Theory playlist will be useful for ESE electrical. 50 hours. The playlist is for 50 hours, Ravi. Each of these playlist antennas that we have derived will also be useful for ESE. The antenna playlist, Mahamarathon playlist, will be useful for ESE. Module 1 will be useful for ESE, for electrical and ECE. Module 2 that we are doing now, this will also be useful for ESE. So once I complete a series, that will be useful for both GATE and ESE. Is that clear, Ravi? Go through this playlist also, where we have covered complete antennas. Go through this playlist where we have covered GATE and ESE for electrical and a part of syllabus for EC. Is it clear, Ravi? Please let me know. Any doubt? Please let me know. So, in our previous sessions, we had completed EM wave propagation in free space, EM wave propagation in materials where sigma not equal to 0, wave propagation through good conductors, good dielectrics and perfect dielectrics. I'll just try to note down the synopsis of the same because it will be useful in the problems. We had covered EM wave propagation in free space. Sigma is 0, epsilon r is 1 and mu r is 1. This was for free space. Then we also calculated it for perfect dielectric. Perfect dielectric, nothing but an insulator kind of a thing. Sigma is 0. Epsilon r is greater than 1. Mu r is greater than 1. Covered it for good dielectrics. For a good dielectric, sigma is far less than omega epsilon. Then we went for good conductor. Sigma is far greater than omega epsilon. Then we went for perfect conductor. Okay. Sigma is very large or infinity. Okay. Any doubts? We completed this theory in the previous sessions. So let us start one by one. We'll start up with conductivity. Okay. Conductivity. Sigma for free space. You can see here it is already mentioned. For free space, conductivity is 0. Similarly, for perfect dielectric, conductivity is 0. For good dielectric, conductivity is very small value. For good conductor, it is a larger value. For perfect conductor, it is infinity. So you can see the journey of conductivity here from 0 to infinity. In this way, we need to do the analysis. Today, there is a very important discussion or analysis based on the behavior of the wave when it is propagating through free space and perfect dielectric. We'll have a discussion where this table will become very important. Next, let me analyze attenuation. How much is attenuation in free space, dear? Anyone? Attenuation in free space. Attenuation 0. Perfect dielectric also attenuation 0. No conductivity here. For good dielectric, attenuation alpha. Sigma by 2 into under root of mu by epsilon. Sigma is less, therefore attenuation also will be less in good dielectrics. All this we have derived in our previous sessions. For good conductor, alpha is under root of omega mu sigma by 2. Good conductor, sigma is large value, therefore alpha is also very large. That means wave will attenuate more in good conductor when compared to good dielectric. For example, if a wave is propagating through an iron rod and the same wave is propagating through a wood log, the wave will attenuate more in the iron rod when compared to wood log. This kind of concept you need to have, which is very, very important. This analysis you need to do because the wave is getting more attenuated in a good conductor. Sigma is infinity, alpha is also infinity, infinite attenuation, not possible. That's the reason wave cannot propagate in perfect conductor, infinite attenuation is there. Now you can see the journey of alpha from 0 to infinity here. 0, 0, very less value, more value and infinity. More is the conductivity, more is the attenuation. Clear? Next. Beta value omega into under root of mu naught epsilon naught already derived. For perfect dielectric, omega into under root of mu epsilon. As you know, mu r is greater than 1, epsilon r is greater than 1, beta value increases. Beta value increases. And here, for a good dielectric, beta value omega into under root of mu epsilon into 1 plus sigma square by 8 omega square epsilon square. This is also derived. So as sigma, now previously sigma was 0, now small sigma got added in good dielectric. Because of this, what is happening? beta is equal to omega into under root of mu epsilon plus omega into under root mu epsilon into sigma square by 8 omega square epsilon square. So as sigma is increasing, beta, what is happening to beta? It is slightly increasing more than omega into under root mu epsilon. Here it is least value, here it has increased, here it has still increased based on the value of sigma. Next, for good conductor, beta is under root of omega mu sigma by 2. Because in good conductor, alpha is beta, same. So what do you get here? Sigma is very large value, so beta is also large. Perfect conductor, infinity. Again, if you see the journey of beta here, here the value is least. The least plausible value is omega into under root of mu naught epsilon naught. Here epsilon naught greater than 1, mu r greater than 1, slightly increasing. Here omega into under root mu epsilon plus omega into under root mu epsilon into sigma square by 8 omega square epsilon square, where sigma is a small value. So naturally the beta value is more than omega into under root mu epsilon because plus is there here. Still increased. Sigma is very large value, still increased. Next infinity because sigma is infinity. Least value possible is in free space. Is it clear? Okay. Next. Sigma, alpha, beta is done. Then velocity, speed or velocity, 1 by under root of mu naught epsilon naught for free space, which is c, 3 into 10 power 8 meter per second. Here v is 1 by under root mu epsilon, mu is greater than 1, mu r is greater than 1, epsilon r is greater than 1. So what happens to velocity? V will be less than c. Will be less than c. Here it is c, here it is less than c. V velocity here 1 by under root of mu epsilon into 1 minus sigma square by 8 omega square epsilon square. Minus means it is less than this value. This is c, this is less than c, this is less than c minus this, and it is still less. So velocity is gradually decreasing. Here velocity under root of 2 omega by mu sigma. Sigma is very large value, so velocity is still less. Here velocity is 0. In good conductor, the velocity is 0. Yes, that's about velocity. So how is the journey of velocity from c, less than c, still less, very less, 0. As the conductivity is increasing, velocity is decreasing. Is that clear? So here velocity is highest, which is equal to c. Here it is the highest, and as you move on, it decreases. This kind of analysis you should have. So that wave propagation will look very simple. Clear? Next. Intrinsic impedance. For free space, under root of mu naught by epsilon naught, 120 pi, 377 ohm. Next, under root of mu by epsilon, that is 120 pi into under root of mu r by epsilon r. Mu r is approximately 1 for most of the cases, epsilon r will be greater value. So eta is decreasing. In general, eta will decrease because mu r is approximately 1 for all practical materials. So eta, let me call this as eta naught. Eta is less than eta naught, decreasing. Then eta under root of mu by epsilon into 1 plus j times of sigma by 2 omega epsilon. Here you can see eta value was real because there is no conductivity. Here once the conductivity will come into picture, reactance component will come into picture in the intrinsic impedance. Therefore it will become complex. That reactance can be positive reactance or negative reactance. Positive reactance indicating inductive, negative reactance indicating capacitive. That's eta. And for a good conductor, eta is under root of omega mu by 2 sigma plus j times of under root of omega mu by 2 sigma. But you know eta is E by h. If you write this in r angle theta form, it is under root of omega mu by sigma angle tan inverse of y by x tan inverse 145 degrees. What does it indicate? It indicates that E electric field always lead H magnetic field by 45 degrees in a good conductor. And you can see here, as sigma is not equal to 0, in both these cases, eta is complex, introducing reactance component. Okay. Now, sigma is infinity here, so eta is 0. It's a very, very important table here. Clear? This table, if you know this table, almost like 50% of this module is done. If you are preparing for competitive exams, if you are preparing for engineering services, then all these derivations I had done in our previous videos, in lecture 2, 3, 4 mainly. You can just go through them. As I told you, our particular series will be useful for both GATE and engineering services. So this table is very, very important. And today, after Poynting theorem is done, we are going to do some important analysis basing on this table. Okay? Now, we will try to do that analysis dear once Poynting theorem is done. We'll start doing the numerics now. Well, fine. So let us start doing this numeric. Consider a uniform plane wave this one, with E naught amplitude of 10 volt per meter, with amplitude E naught is 10 volt per meter and frequency 1.1 gigahertz, traveling in air, eta 120 pi, and incident normally on a dielectric medium with complex relative permittivity and permeability epsilon r and mu r as shown in the figure. Mu r, epsilon r both are complex. It is incident on this medium. Eta 2 is also given 120 pi. Can anyone tell me why? This is medium, no? Eta must vary. But you are given 120 pi for this also. 120 pi or 377 ohm is for free space. But why you are given 120 pi here? Can anyone tell me? Find magnitude of E after traveling 10 centimeter into the medium. Find the magnitude of V after traveling 10 centimeter into the medium. I want the magnitude of E after traveling 10 centimeter into the medium. So how to find this dia? E naught is given 10 volt per meter, frequency is given as 1.1 gigahertz, eta 1 is 120 pi ohm, eta 2 is also 120 pi ohm. First someone tell me why eta 2 is 120 pi ohm. Think on this. For free space it must be 120 pi. But given that it is a medium and still it is 120 pi. Why it is 120 pi? Think on this, dear. Because eta is under root of mu naught by epsilon naught. This will be 120 pi for free space. But for a given medium, eta is under root of mu by epsilon 120 pi into under root of mu r by epsilon r. But here not only mu r and epsilon are complex, but they are equal. That's why they are getting cancelled out and you are getting 120 pi. If you are getting confused here, you will think that eta 2 is wrong. The data given is wrong, but that is not the case here. Yes, it will be 120 pi again. Because mu r and epsilon are the same. Got the logic? This eta logic is done. I need to find the value of magnetic field after it is traveling 10 centimeter into the medium. What is E? E is equal to initial amplitude E naught, 10 volt per meter. E naught into e power minus alpha z. Of course, you'll write into e power j of omega t minus beta z, that is phase term. E power j of omega t minus beta z, already we have derived these things in theory into some direction. For example, AX. This is phase term, direction remove, phase term neglect, because we are trying to understand the magnitude change, the amplitude change of electric field. So considering this particular term, what is E now? E is E naught. E is E naught is 10 volt per meter into e power minus z, e power minus alpha into z. Z is the distance traveled into the medium. Wave is propagating in z direction, am I right? So, how many centimeter it is? 10 centimeter. Z is 10 centimeter. 10 into 10 power minus 2. That is E is 10 into e power minus alpha by 10. So if you know alpha, your work is done. So try to find the alpha and substitute here, everyone. Everyone try to find the value of alpha and substitute here. If you know alpha, this problem is done. Try to find it. Try to find the value of alpha. Yes, how to find alpha? For a good dielectric, you know alpha is 0, or what do you call this? Sigma value is not mentioned here. Trying to consider that as a perfect dielectric. Consider perfect dielectric. Alpha value is 0. If gamma is alpha plus j beta, gamma will become j beta. Considering a perfect dielectric, how do you consider it as a perfect dielectric? Why do you consider the dielectric medium as a perfect dielectric? Sigma value is not given. So, as sigma is 0 and it is not free space, sigma is 0 and is not free space, it must be perfect dielectric. Because epsilon r is greater than 1, mu r is greater than 1. So it must be perfect dielectric. Am I right? So considering this as a perfect dielectric, for perfect dielectric alpha is 0, the gamma is alpha plus j beta, alpha is 0, gamma is equal to j beta. How much is beta value? Omega into under root mu epsilon. Gamma is j into beta omega into under root mu epsilon. Gamma is j omega 2 pi f under root of mu naught epsilon naught under root of mu r epsilon r. Gamma j times two pi, frequency f is 1.1 gigahertz, 1.1 into 10 power 9 In previous class also we have discussed this. Under root of mu naught epsilon naught is 1 by c. 1 by 3 into 10 power 8. Under root of mu r epsilon r. Under root of mu r is 1 minus j2 into 1 minus j2. Under root of 1 minus j2 whole square, which is 1 minus j2. Which is 1 minus j2. Clear? So from this gamma, j times 2.2 pi into 10 power 9, 2.2 pi into 10, 10 power 8 and 10 power 8 get cancelled, by 3 into 1 minus j2. For gamma is 22 pi by 3, j times 22 pi by 3 into 1 minus j2, j into j square. So this is j times 22 pi by 3 minus j into j square, minus 1 minus or minus plus 44 pi by 3. Comparing gamma is alpha plus j beta, (44 pi by 3) plus j times of 22 pi by 3. Comparing, you will get the value of alpha. Alpha is 44 pi by 3. Calculate and tell me the answer. 44 pi by 3. Calculate here. (44 pi by 3) calculate. Yes. What is the answer? (46.05). 44 pi by 3, which is 46.05. That's the value of alpha. But I got a doubt here. We are getting attenuation alpha here. But if you remember, we started that as sigma is 0. We consider it as a perfect dielectric. Therefore, alpha is 0. We started our discussion with alpha is 0. Thereby, gamma is j times of beta. Beta is omega into under root mu epsilon. And we had ended up with alpha. Can anyone tell me why it is happening? We started our discussion with alpha is 0. But later we had ended up with alpha value. Why so? It is actually a perfect dielectric. Alpha must be 0. It is a perfect dielectric. Alpha must be 0. But why you are getting alpha? Even though it is perfect dielectric, you are getting alpha because what? Because mu r and epsilon r are complex. As mu r and epsilon r are complex, instead of real values, they are complex values. These complex values are resulting in losses. That losses, because of mu r and epsilon r being complex, is given by attenuation. For example, if you think mu r and epsilon r values are 2, each value is 2. Mu r is 2, epsilon r is 2. If you substitute here, Instead of 1 minus j2, you are substituting under root of 2 into 2, under root 4, which is 2. Then this gamma will always be imaginary only, alpha will always be 0 only. It will not lead to any attenuation. Because these values are complex, it is leading to imaginary value. This imaginary value is changing to complex value, which is leading to alpha value. You need to understand this. So why is this attenuation happening here? Attenuation is happening because mu r and epsilon r values are complex in nature. That's very, very important concept. You need to understand that concept very clearly. More than this mathematical structure, you must understand the concept here. Substituting alpha value as 46.05. This is 10 times e power minus 46.05 by 10 minus 4.605. Calculate. Calculate and tell me. 10 into e power minus 4.605 first. Yes dear, first. Ten into e power minus 4.605. This will be 0.01 into 10, 0.1 approximately. To be more clear, 0.0999 it will be approximately 0.1 volt per meter. Option B is the answer. Very important model. It's a very important model, dear. Is that clear? Okay. Fine. Any doubts so far? Any doubts so far? So next. The next one. Try to solve this, dear. Electric field is given by E is equal to (30 cos of 10 power 80 minus 1 by root 2 1 by root 2x into AY volt per meter in a medium epsilon r is 8 and mu r is 2. Tell me dear, one by one. Try to tell me the answer one by one. Yes, first. Fast here, everyone. So what's the answer? First question answer. Quick. You need to answer. Just waiting for your answers. Yes. My chat box not working. The answers are not getting updated. Yes. You need to answer, dear. Very easy question. Electric field is given. Is asking us to find direction of propagation. It is of which form? Omega t minus beta x. Omega t minus beta x means wave is propagating in which direction? Positive x direction. Finished. Next, find velocity of propagation. How much is omega given here from comparison? 10 power 8 radian per second. How much is beta given? 1 by root 2 radian per meter. What is velocity? Omega by beta. 10 power 8 by 1 by root 2 radian per second by radian per meter, meter per second. Unit of velocity. This is velocity is root 2 into 10 power 8 meter per second. Direction is positive x, means either C or D. Answer is either C or D. Here answer you got as root 2 into 10 power 8. Root 2 into 10 power 8. Most of you people will go for D because it is visible. Root 2 into 10 power 8, root 2 into 10 power 8, answer is matching. You need not calculate intrinsic impedance and magnitude of H. You will go for the answer as D. If you are doing so, then you are wrong. What was the problem here? Why the answer is not D, anyone? Why the answer is not D, dear? Can anyone tell me why the answer is not D? Think and tell me, dear. Think and tell me why the answer is not D. Anyone? Anyone? Fine. Simple logic here. You need to pay the attention here. Velocity of propagation. Root 2 into 10 power 8 meter per second. Root 2 into 10 power 8 is available, but you see the unit here. Kilometer per second. So convert this into kilometer. 1.414 into 10 power 5 kilometer per second. This is 141400 kilometer per second. Therefore, that's the reason why it is not D. Should be very careful, okay? It must be C. You need not verify the last two because it is done already. With this combination, only one option is there. You need not verify. If you are very much sure, then you need not verify. For our practice sake, we will do it in the class. Intrinsic impedance. Intrinsic impedance formula under root of mu by epsilon 120 pi into under root of mu r by epsilon r 120 pi into under root of 2 by 8 under root of 1 by 4 1 by root 4 1 by 2 120 pi by 2 60 pi. Ohm. Yes, matching. Last one, magnitude of H. Mod E by mod H is eta. Magnitude of E is 30. 30 by mod H is eta value 60 pi. Mod H is 30 by 60 pi. 1 by 2 pi. 1 by 2 pi. Option C is the answer. Is it clear? You need to interact and answer here, so it will become very easy for you. Okay, next. In a perfect dielectric medium, omega is equal to ten power 8 radian per second. Epsilon r is 4. Mu r is 4. Is asking find value of beta. In a perfect dielectric, beta is omega into under root mu epsilon. Omega 10 power 8 under root of mu naught epsilon naught into under root of mu r epsilon r. As you know, under root of mu naught epsilon naught is 1 by c, that is 1 by 3 into 10 power 8. Under root of mu r epsilon r under root of 4 into 4 under root 16, which is 4. Beta value is 4 by 3. Answer must be either B or D. Next, find eta. Eta is under root of mu by epsilon 120 pi into under root of mu r by epsilon r 120 pi into mu r epsilon r values are same. So it is 120 pi ohm. Thereby it is 120 pi ohm. Next. Velocity is simply omega by beta. Omega is 10 power 8. Beta, you got it as 4 by 3. It's 3 by 4. Into 10 power 8. 3 by 4 into 10 power 8. Option D is the answer. Is that clear? Next. In a good conducting medium, omega is 10 power 8 into pi radian per second. Sigma is 10 power 5 mho per meter or Simon per meter. Mu r is 2. Given that it is a good conductor, good conducting medium, good conductor, find alpha. Alpha for a good conductor is under root of omega mu sigma by 2. That is under root of omega 10 power 8 into pi. Mu naught into mu r. Mu r is given as 2. Mu naught 4 pi into 10 power minus 7. Sigma 10 power 5 by 2. The cancel of alpha is under root of 4 pi square 10 power 8 into 10 power minus 7, 10 into 10 power 5, 10 power 6. Alpha is 2 pi into 10 power 3. 2000 pi. Nepper per meter. 1 nepper. How much is 1 nepper in terms of decibel? 1 nepper is 8.686 decibel. Default unit is neppers. Clear? 2000 pi nepper per meter, either C or D. Beta, for good conductor, beta under root of omega mu sigma by 2. The logic here is alpha and beta are same for good conductor, so need not do it again. You will get again 2000 pi nepper per meter. 2000 pi nepper is here but not in D. Therefore D is not the answer, C is the answer. That is one logic. By this you need not do this. Last one. What is last one? Delta. Delta is 1 by alpha. 1 by 2000 pi. So answer, option C is the answer. Almost it took 1.5 or 2 minutes for me to solve this problem. It took at least 1.5 or 2 minutes for me to solve this problem. You can do it in 2 seconds. Just read the question, 2 seconds you will find the answer. How? If you know that, or if you apply the logic, for a good conductor, alpha is beta. Given good conducting medium is asking us to find alpha and beta. Here alpha, beta not same, alpha, beta not same, alpha, beta not same. Only for C it is there. Here the options are weak actually. You need to capitalize this kind of thing using concept. That's why practice is very important. For competitive exams, practice and presence of mind are very, very important. Even though you know the logic alpha is equal to beta, after solving the complete value of alpha, you had used it here. But rather, if you see the options carefully, you can use it initially only without any calculation. So in this way, you need to save this small 1 minute, 30 seconds here and there, such that they'll sum up to 10 or 12 minutes, which gives you advantage over the other competitors. That's why practice is very, very important here. You need to do practice and also keep your presence of mind. Is it clear? Next problem. Try to solve this. This is very simple. Very simple. Try to solve this. Try and solve this, dear. What's the answer? Identify the true statements in a good conductor. Alpha is equal to beta. Yes, true. We know that for a good conductor, alpha is always equal to beta. True. Statement 1 is true. Next, in a good conductor, beta is 1 by alpha. You know, beta is 1 by delta. You know, delta penetration depth is 1 by alpha. But for good conductor, alpha is beta. If delta is 1 by beta, implies beta is 1 by delta. Yes, true. Penetration depth is less at high frequencies. Penetration depth delta is 1 by alpha is under root of 2 by omega mu sigma, under root of 2 by 2 pi of mu sigma, that is 1 by under root of pi of mu sigma, implies penetration depth delta is proportional to 1 by under root f. At higher frequencies, penetration depth is very less, and this less penetration depth is called as skin depth. and at lower frequencies penetration depth is more. Generally you call it as penetration depth only. When it is more value you call it as penetration depth, but when it is less value you call it as skin depth. What I mean to say is, if you take a conductor, low frequency signal will penetrate more into the conductor and travel like this. But if you send a high frequency signal like this, it will penetrate less into the conductor and travel. High frequency signal confine themselves to the surface of the conductor because their penetration depth is less. Because their penetration depth is less. It cannot propagate much into the conductor. It will die soon. Why it will die soon? Why it will die soon? E is equal to E naught into e power minus alpha z into e power j of omega t minus beta z into ax is the expression for E for a wave propagating in z direction, electric field along x direction and magnetic field along y direction. This is omega t, gives you the change of phase with respect to time, and beta z will give you change of phase with respect to space. This is phase term. If you consider the amplitude variation, attenuation, amplitude variations, E is equal to E naught into e power minus alpha z. Now, case 1, when z is 0, initial value, it has not travelled on the surface of the conductor, I mean to say. E is E naught into e power 0, that E is equal to E naught. Yes, initially amplitude is E naught. It is correct. It is correct. Now the travel has started. The wave is penetrating into the conductor by value of delta. Delta is penetration depth. So it has travelled to some value and it has travelled to a distance of delta. Now what happens? E is equal to E naught into e power minus alpha. Z is delta, substituting delta. E is equal to E naught into e power, alpha is 1 by delta, substituting e power minus 1. E is equal to E naught into 1 by E. E is 2.718. Therefore, E is equal to E naught into 1 by 2.718. This is 1 by 2.718 is 0.368 of E naught. Therefore, I can say that, good morning Bhupati. Therefore, I can say that when the wave is penetrating into the conductor, when it has travelled a distance of delta, its value is already 36.8% of its initial value. I'll give an example, don't worry. See, this is a conductor. Let the initial amplitude is 10 volt and delta value is 1 centimeter. So after it has travelled 1 centimeter, at this point, what will be the amplitude of the wave? 3.68 volt, because it will become 0.368 of initial value. So 10 volt will become 3.68. How much it has reduced? Almost 62%. 62% reduction. 62 or 63% reject. 63% reduced. It has traveled 1 centimeter. 63%. So approximately at 1.75 centimeter, what happens? The amplitude will become 0. That's why this will act as a benchmark to understand how far the wave can penetrate into the conductor. I am not saying that at penetration depth the value will become 0, but penetration depth will make you understand. Using penetration depth we can understand at what value it will become 0. Is it clear? Everyone, almost 60% attenuation is done. Half of this, not even 1.75 here, around 1.5 I think. Around 1.5 centimeter it will become 0. 1.5. 1 centimeter already from 10 to 3.68 has become. At 1.5 or before 1.5 only, the value will become 0. Clear? So this is the speciality of penetration depth. We can understand the change of amplitude of the signal with the distance. What is penetration depth giving you? Penetration depth will tell you the change of amplitude of the signal with respect to distance. Can anyone tell me who will tell you the change of amplitude of the signal with the time? The change of amplitude of the signal with respect to distance is given by penetration depth. Can anyone help me out? Which parameter will tell you the change of amplitude of the signal with respect to time? With respect to time. Think and tell me. Penetration depth is telling you the change of amplitude of the signal with respect to distance. Who will tell you the change of amplitude of the signal with respect to time? The change of amplitude of the signal with respect to time is given by relaxation time. Is given by relaxation time. Tau. Formula epsilon by sigma. Relaxation time. Relaxation time is the time taken by the wave to decrease to 36.8% of its initial value. That means what? Relaxation time and penetration depth are saying the same thing. But penetration depth is telling in terms of distance and relaxation time is telling in terms of time. But they are indicating the same concept. You know, most of the students don't know that they both indicate the same concept. Is it clear? See dear, from continuity equation, del dot J is equal to minus dou rho V by dou T. This is continuity equation. J is sigma E. Del dot sigma E is minus dou rho V by dou T. Sigma times of del dot E is minus dou rho V by dou T. We know from Gauss law del dot D is rho V. D is epsilon E. Del dot epsilon E is rho V. Del dot E is rho V by epsilon. Replacing this by rho V by epsilon. Is equal to minus dou rho V by dou T. Separating the variables, sigma by epsilon of dou T minus sigma by epsilon of dou T is 1 by rho V of dou rho V. Integrating on both sides, minus sigma by epsilon integral of 1 dt into t plus integration constant, let it be c, integral of 1 by rho v dou rho v ln of rho v. Let c is integration constant, which is equal to ln of rho v naught, where rho v naught is initial volume charge density, minus sigma by epsilon of t plus ln of rho v naught is ln of rho v, implies ln of rho v minus ln of rho v naught minus sigma by epsilon into t. Ln of rho v by rho v naught is sigma by epsilon you have a minus here, I think I'm right, minus sigma by epsilon into t, implies rho v by rho v naught is e power minus sigma by epsilon into t. Rho v is rho v naught into e power minus t. Sigma by epsilon is 1 by tau. Tau is epsilon by sigma. E power minus t by tau. This is the expression, you got it from continuity equation. Listen carefully. Now at t is equal to 0, again same, rho v is rho v naught, charge is same. When the time will lapse and will reach t is tau, rho v is rho v naught into e power minus 1. Rho v is again 0.368 of rho v naught. Indicates what? Indicates what? Relaxation time is a time taken for the charge to decrease to 36.8% of its initial value. Listen carefully. Rho v is equal to 0.368 of rho v naught. E is equal to 0.368 of E naught. What is this? Penetration depth. What is penetration depth telling you? Penetration depth is telling you that penetration depth is the distance traveled by the wave to decrease to 36.8% of its initial value, field component. Whereas relaxation time is telling you the time taken for the charge this is delta, this is tau. Time taken by the charge to decrease to 36.8% of its initial value. This is talking in terms of distance. This is talking in terms of time. This is talking about field. This is talking about charge. See how closely they are related. But if you don't compare, generally students will feel that these both concepts are different. But actually it is not the case. These both concepts are not different here. They are one and the same. Got it? So now, where we are here, penetration depth is less at high frequency. At higher frequencies, the penetration depth is less, which is also called as skin depth. True. Penetration depth is more at high frequency. No, it is very less. This is wrong. This is true. 1, 2, 3. Option A is the answer. Of course, the answer is very simple. We had extended the concept and understood penetration depth and relaxation time parallelly. That's the reason I had not explained it during theory. I want to explain both these concepts parallelly. Is it clear? Yes. Try to solve the next one. Try to solve the next one, dear. Yes. What's the answer? Find the last tangent value. For good conductor, last tangent, for good conductor, sigma is far greater than omega epsilon. Sigma by omega epsilon is far greater than 1. Sigma by omega epsilon is greater than 100. For good conductor, it must be greater than 100. 0, not the case. 110, infinity, 110. 3 chances are there. 3 chances are there. Let us see. Not C, dear, not C. Greater than 100, but we can't say infinity, no. Chance is there, B, C, D, we'll see. Good dielectric. For good dielectric, sigma by omega epsilon is far less than 1. Is less than 1 by 100. Less than 1 by 100. It can be this. It can be this. It can be this. Less than 1 by 100. So all the options are still holding good. Next, perfect conductor. For perfect conductor, how much is sigma? Infinity. No doubt there. Infinity. That's why B and C are outruled. Now you check. Sigma by omega epsilon must be greater than 100. 110 greater than 100. Correct. Less than 1 by 100. 1 by 110. Less than 1 by 100. Correct. Sigma is infinity. Correct. Perfect dielectric. Sigma is 0. Correct. Option D is the answer. Got it? Bhupati? So by that logic, it is not C, but it is D. Next question. Yes. Identify the true statements velocity with which the wave propagates in free space is more than that of dielectric medium with finite mu r and epsilon r. Is this statement true or false? First statement. Just tell me first statement. True or false? Velocity with which the wave propagates in free space is velocity of light. C. 3 into 10 power 8 meter per second. Is more than that of dielectric medium with finite epsilon r and mu r. Velocity with which the wave propagates in a given medium is C by under root of mu r epsilon r. Finite mu r epsilon r. Mu r is greater than 1, epsilon r is greater than 1. So we will decrease. Now you see. Velocity with which the wave propagates in free space means C is more than that of dielectric medium with finite mu r and epsilon r. For a dielectric medium with finite mu r and epsilon r, it is V, which is less than C. That means the velocity with which the wave is propagating in free space C is greater than V. True. I told you in theory also today. What we discussed in theory, if you remember, you can see here. Velocity is highest in free space. Decreases and it becomes 0 in perfect conductor. That's why if you know this logic, you need not do this analysis, because if you know this logic, then you can directly write the answer. Next. Second one. Intrinsic impedance of free space. Intrinsic impedance of free space eta naught 120 pi 377 ohm approximately is less than intrinsic impedance of a medium 120 pi into under root of mu r by epsilon r. 120 pi into under root of mu r is 1, epsilon r is greater than 1. Eta will be less than 120 pi, that is less than eta naught. Intrinsic impedance of free space is less than intrinsic impedance of the medium. No, reverse. So this statement is false. Bhupati, 100% correct. Very good, Bhupati. Option A is the answer. Very good. Is it clear? Yes. Solve this now. Solve this, dear. Yes. Try to solve this. H is equal to 450 sine of 10 power 8t minus x Az ampere per meter. The magnetic field of an EM wave in perfect dielectric. In a perfect dielectric, the epsilon r of the medium is find out, tell me the answer. C. Very good, Yadav. If you see and compare this equation, how much is omega? From this equation, omega is 10 power 8 radian per second, and beta is 1 radian per meter, because the standard form is H is H0 times of sine of omega t minus beta x Az ampere per meter. So if you compare, you get beta and omega in this way. Given that it is a perfect dielectric, beta value for a perfect dielectric is omega into under root mu epsilon. But we know beta is 1. 1 is omega under root of mu naught epsilon naught into under root of mu r epsilon r. 1 is omega is 10 power 8. Under root of mu naught epsilon naught is 1 by c. 1 by 3 into 10 power 8. Mu r value is not given, so we can take it as 1 into under root epsilon r. Implies under root epsilon r is 3. Epsilon r is 9. Absolutely correct, Yadav. Option C is the answer. Very good. Bhupati, did you got the answer? Got it, dear? Very good. Next question. Okay, try to solve this now. Try to solve this. If the phase velocity of a plane wave in a perfect dielectric, given that it is a perfect dielectric, phase velocity of a plane wave in a perfect dielectric is 0.4 times its value in free space, that is C. So he has given that Vp is 0.4 C. Then epsilon r of the medium is what is epsilon r of the medium? Try to solve this. Given it is a perfect dielectric, Vp is under root of 1 by under root of mu epsilon, nothing but C by under root of mu r epsilon r. Given that Vp is 0.4 times of C, .4 times of C is C times C by under root of mu r epsilon r. Mu r value is not given, so take it as 1. C and C get cancelled. 0.4 times or 0.4 is equal to 1 by under root epsilon r. 4 by 10 is 1 by under root epsilon r. 10 by 4 is under root epsilon r. 2.5 is under root epsilon r. Epsilon r is 6.25. Very good. Bhupati, very good dear. Option A is the answer. No, not B, not B, Yadav. It is A. It is A. It is A. Clear? Next question. If the electric field intensity associated with the uniform plane electromagnetic wave traveling in a perfect dielectric medium is given by E of z comma t is equal to 10 cos of two pi into 10 power 70 minus 0.1 pi z into AY volt per meter. The velocity of the travelling wave is from the given data, amplitude of electric field 10 volt per meter, omega 2 pi into 10 power 7 radian per second. Beta 0.1 pi. Find it here, find it. So what's the answer? B, absolutely correct. B is absolutely correct. Velocity V is omega by beta. Two pi into 10 power 7 by 0.1 pi. Pi get cancelled. It's 2 into 10 power 8 meter per second. This is a previous year question paper. Question PYQ. In wave propagation, 90% of the time questions will be easy. But beforehand itself, students will have this phobia about wave propagation. So they don't attempt the question at all. Actually, the question will be very easy. In order to overcome this, we are taking this series of wave propagation. That's why I'm trying to take a very elaborated wave propagation series. Complete theory, previous year questions, practice questions of wave propagation will be covered with fundamental concepts. Only our fundamentals we took 3 hours. If you remember, this particular playlist of wave propagation will be very much helpful for you in overcoming that phobia. Once you conquer wave propagation, EMTL looks very easy. I'm right. So next question. We'll go for the next question. Yes. Try to solve this. Try to solve this. The E of an EM wave, that means the electric field of an EM wave, is given by 50 sine of 10 power 70 plus kz AY volt per meter. Which one of the following are true? Yes, dear. One by one you tell me. A is true, B is true, C is true, D is true. One by one you verify and tell me, dear. Start doing. Start doing. Start doing, dear. The wave propagation is along y-axis. It's very clear that these are the form omega t plus beta z, indicating that the wave is propagating along negative z direction. But given here it is y, which is wrong. Then wave attenuate as it travels. No information about conductivity is given. We cannot say that it attenuates. By default condition is free space condition. Alpha is 0. It won't attenuate because conductivity is not given. Conductivity is not given. So what will be the answer? B. What is K, Bhupati? What is K? wave number means beta, phase shift constant. How much is omega given here? 10 power 7 radian per second. Condition is free space. Beta, wave number. Omega into under root of mu naught epsilon naught. 10 power 7 into under root of mu naught epsilon naught is 1 by c. 3 into 10 power 8. 1 by 30. 0.033. But given 0.33 here, this is also wrong. So all the three A, C, D are wrong. You need not verify. B must be your answer. The verification of B's are not that difficult. Wavelength. Beta is 2 pi by lambda. Lambda is 2 pi by beta. Two pi by 0.033. This will be 188.5 meter. Done. Is it clear? Approximately 6.28 by 0.033 if you do, you get 188.5. Option B is the answer. Next. Yes, next one. What is the answer? This is purely theory. This is purely theory. Basing on theory, you can tell this. Basing on theory, we can directly tell this. If alpha C, beta C and Vc are attenuation constant, phase shift constant and velocity of wave in good conductor, alpha D, beta D and Vd attenuation constant, phase shift constant and velocity of wave in good dielectric. Which of these condition is true? If you don't know the concept, you can't do this because no data is given. Is there any data given to solve? No. If you know the concept, we can solve in 2 seconds. If you don't know, it's gone. That's why concept oriented questions are very, very important. You should learn strong concept. Tell me the answer here. Try to tell me the answer. I will explain the concept, don't worry. Any guess on the answer? Anyone? Alpha C, beta C and VC, attenuation constant, phase shift constant and velocity, good conductor. Alpha D, beta D and VD, attenuation constant, phase shift constant and velocity for good dielectric. Which of these statements are true? When a wave is propagating in a good conductor like iron, it is propagating good dielectric like wood. Tell me what happens. In iron it will get more attenuate, or in wood it will get more attenuate. Alpha value sigma by 2 into under root of mu by epsilon for good dielectric. For good conductor, alpha value under root of omega mu sigma by 2. For good dielectric, sigma is far less than omega epsilon, or sigma is very small value. Sigma is far greater than omega epsilon, very large value. If you compare, this is alpha C, attenuation in good conductor. This is attenuation in good dielectric. Sigma is small value. Here sigma is large value. Where you will have more attenuation? Where the wave will get more attenuated? In iron or wood? It gets more attenuated in iron. The wave will get more attenuated in iron. Exactly opposite of circuit theory. In circuit theory, good conductivity, more conductivity is good. Here more conductivity leads to more loss. So, wave gets more attenuated in good conductor when compared to good dielectric. Beta, if you see the phase shift now, beta and alpha are same for good conductor. So beta, sigma is very large, so beta is also very large. Beta is also very large because for good conductor alpha is equal to beta. For good dielectric, how much beta you will get? Omega into under root of mu epsilon 1 plus sigma square by 8 omega square epsilon square. Sigma value is less. When you compare these two things, beta D will be less and beta C will be more. Again, it undergoes more phase shift. In good conductor, when compared to good dielectric. Next, if you see the velocity, when the wave is propagating in good conductor, it is attenuating more. But what about velocity? What about velocity? Omega by beta. For good conductor velocity, under root of omega by beta, under root of 2 omega by mu sigma. Sigma is very large value, so velocity is very less. Substitute omega by beta. This will move up. One root will get cancelled. So velocity is under root of 2 omega by mu sigma. Sigma is very large value for good conductor. Vc is very small. In good conductors, the wave will propagate with very low velocity. Very low velocity. Whereas for good dielectric, if you see the velocity Vd 1 by under root mu epsilon 1 minus sigma square by 8 omega square epsilon square. It is less but not as less as in good conductor, because sigma value is a very small value here. Here sigma is very large value. So we can say in good conductor the wave will propagate with less velocity when compared to good dielectric. Vc is less than Vd. If option D is the answer. Very, very important question. Why? Because there is no data. Is there any data given here? Nothing. Just a concept. But you should know all this concept that I had explained now. At back of your mind, you should know all these formulas. Then only you can compare and solve the question. Clear? Very good, Bhupati. Next question. Yeah, try to solve this. Next question. Electric field component of a plane wave traveling in a lossless medium is given by E is equal to 2 cos of 10 power 8t minus z by root 2 into AY volt per meter. Wavelength is dash meter. Solve it here, solve it, solve it. What is the answer? Try to solve. What is the answer? Yes, yes, fast. What is the answer, dear? See here, dear. This given question, how much is omega? (10 power 8 radian per second). How much is beta? 1 by root 2 radian per meter. How much will be velocity? Omega by beta. 10 power 8 by 1 by root 2. Root 2 into 10 power 8 meter per second. This is V value. I want lambda. F is V by lambda. Lambda is V by F. Root 2 into 10 power 8 by omega is 2 pi F. F is omega by 2 pi. This is 2 root 2 pi. 2 root 2 pi. Substituting. Lambda will be 8.885 meter. Lambda will be 8.885 meter. This is actually lengthy procedure. Long procedure. Long. Not wrong. Long procedure. Shortcut. Given beta is 1 by root 2. Beta is 2 pi by lambda. Lambda is 2 pi by beta. 2 pi by 1 by root 2. 2 root 2 pi. Done. Finished. Option B is the answer. I prefer this one. But for procedure's sake, I explained this also. In either the way you do, it will be correct answer only. Nothing to worry. You should know the procedure also. That's it. Clear? Yes, yes, yes. Very good. This is a very good problem. Try to solve this. A plane wave propagating in air with E is equal to 8ax plus 6ay minus 5az e power j of omega t plus 3x minus 4y volt per meter is incident on a perfectly conducting slab at x less than or equal to 0. The reflected wave is, yes, tell me the answer here. The perfect conducting slab. The perfect conducting slab x is 0 and this slab is at x is less than or equal to 0 positioning. A plane wave in air with electric field given is incident on this slab. Incident wave. Incident wave. Is asking find the reflected wave. Find the reflected electric field. Incident wave and this is reflected wave. This is incident electric field. Is asking find reflected electric field. How to find? This is EI. It's asking us to find ER. ER is minus EI. Multiply with minus 8AX minus 6AY plus 5AZ into e power j of omega t plus 3x minus 4y. This is what you generally write. But is it correct? Or shall I make some changes to this? If I need to make some changes to this, why I need to make? Can anyone throw some light on this? Anyone? Bhupati Yadav, anyone dear? Try and find the answer. Did you got the logic? Logic is very simple. Listen here. ER is equal to minus EI. But this sign won't change. Why? Why this will not change? It will be same as incident only. It will be minus 5AZ only. It will not change. Why? Because if you see the orientation of the wave, it is in the XY plane. Beta x into x plus beta y into y. No z variation. So either in incident or in reflected, there won't be any change. It will be as it is. That's why minus 5AZ. Now, any more changes we need required? If you see this carefully, this is x is 0. This is x is less than 0. This is x is less than 0. And this is x is greater than 0. That means this is x-axis. This is x-axis. So the wave, incident wave is traveling from x greater than 0 to x is 0. Means x is decreasing. X is decreasing, that's why plus 3x. Omega t plus beta x. Omega t plus beta x means in concept I told you. Omega t plus beta x means negative x direction. Incident wave is from x greater than 0 to x is 0. It is in the decreasing x direction. Decreasing x direction means plus 3x. Now the reflected wave is moving from x is 0 to x greater than 0. X increasing direction. So what change I should do? What change I should do? Omega t minus beta x. That means what? This plus 3x now will become minus 3x. These two changes are very, very important. Both the changes are conceptual changes. And not done anything here. It's all concept. And not substituted any formula or something. That's why these concept oriented questions are very, very important. And in theory, rigorously we are covered these kind of concepts. So answer is minus 8ax, minus 6ay, minus 5az, e power j of omega t minus 3x minus 4y volt per meter. Option C is the answer. Is that clear? Yes, Karna. Now, try to solve this question, dear. Distilled water at 25 degrees Celsius is characterized by sigma is equal to 1.7 into 10 power minus 4 mho per meter. Epsilon is equal to 78 epsilon naught. At frequency F is 3 gigahertz. Its loss tangent tan of delta or tan phi is equal to dash. Find out, dear. Find out. Very good. No. Reddy, it's no, wrong. Do it carefully. Do it carefully. Find the answer, dear. Loss tangent tan phi sigma by omega epsilon. Of course, where phi is 2 times of theta n, where theta n is angle of intrinsic impedance. Sigma by omega epsilon. Sigma by omega 2 pi f epsilon naught into epsilon r. Sigma 1.7 into 10 power minus 4 by 2 pi f is 3 gigahertz. 3 into 10 power 9 epsilon naught 10 power minus 9 by 36 pi epsilon r. From this epsilon naught into epsilon r is 78. Solve it. Now you solve and tell me the answer. 10 power 9 and 10 power minus 9 cancels out. Pi and pi get cancels out. Solve it, dear. Solve it and tell me the answer. Fast. Okay, now we'll verify. 2 into 3, 6. 6 times. So this will be 1.7 to 10 power minus 4 by 13. 1.7 1.3 into 10 will move up 10 power minus 5. 1.7 by 1.3, 1.3 into 10 power minus 5. That's the value. Option A is the answer. Yes, Reddy. Correct. Bhupati, you need to try. Others, you also need to try, okay? Fine. Next question. In a good conducting material, an EM wave at frequency 100 megahertz has a depth of penetration of 5 micrometer. Vp, phase velocity of the wave, is dash. Very good question. This is previous year question paper. Very important model. Concept oriented. Please try to solve. So what is the answer? Is the data sufficient? In a good conducting material, an EM wave at a frequency 100 megahertz has a penetration depth of 5 micrometer, then Vp, Vp phase velocity, omega by beta. Omega, of course, you can find when F is given. This is 2 pi F by beta. But how to find beta? Is the data sufficient? Let me know. Is the data sufficient? How to find beta from delta? Is the data sufficient? Again, it's a concept. Good conducting material. For good conductor, we know that for good conductor, alpha is equal to beta. And we also know that delta is 1 by alpha. And for good conductor, alpha is beta. So delta is 1 by beta. From this, 1 by beta can be replaced by delta. 2 pi f into 1 by beta can be replaced by delta. Sufficient. Very good. Bhupati, very good dear. 100 into 10 power 6 into delta 5 micrometer, 5 into 10 power minus 6. This is 1000 pi meter per second, which is pi 10 power 3 kilometer per second. Pi kilometer per second. Option B is the answer. Very good, Bhupati. Good job, good job. These kind of concepts, Bhupati, we need to remember. In wave propagation, 1, 2, 3, 4, 5. These 5 concepts are there. If a question appears from any of these concepts, you will do it very quickly and with more accurate. Your accuracy will be more. That's why your hard work will pay when you try to streamline your energy in a good way. If I am not wrong, you might have gone through this question somewhere down the line previously and practiced it, am I right? That's why it is very easy now for you. So we need to do lot of practice, dear. Yes. Is your preparation for 2022 done? Bhupati? I think you are giving 2022, am I right? You are giving 2022 exam? Good. Next question. Okay, try to solve this now. A material has a conductivity of sigma is 10 power minus 2 mho per meter and a relative permittivity of 4. The frequency at which conduction current in the medium is equal to displacement current. Find frequency. Given condition is conduction current is equal to displacement current. Again, this is a concept. According to concept, in any given medium, when conduction current density is equal to displacement current density, what is the value of loss tangent here? Without calculating, you can tell directly because I told you in the theory. What is the value of loss tangent? In any given medium, when conduction current density is equal to displacement current density, what is the value of loss tangent here? In any given medium, when JC is equal to JD, JC conduction current density, sigma E, JD displacement current density, dou D by dou T. Mod of sigma E is equal to mod of dou by dou T, J omega, D is epsilon E. mod of sigma E is equal to omega epsilon E. E get cancelled. Sigma by omega epsilon, lost tangent, tan of phi, where phi is 2 times of theta n, is equal to 1. So it's a direct shortcut. In any given medium, when JC is equal to JD, lost tangent is equal to 1. So if you know this concept, it will save this time. You need not calculate and it will be more accurate. So we know that as JC is equal to JD, sigma by omega epsilon is equal to 1. Sigma given 10 power minus 2 by 2 pi f. Epsilon is epsilon naught into epsilon r. 10 power minus 9 by 36 pi into epsilon r is given as 4. Done. So this is equal to 1. Implies 36 pi into 10 power minus 2 by 8 pi f into 10 power minus 9 is equal to 1. Pi get cancelled. 8 1 times, 4.5 times, 4.5 into 10 power 7 is equal to f. Or f is 45 into 10 power 6. Implies the value of f is 45 megahertz. Option A is the answer. Is it clear? If you know that concept, directly you will start solving this from sigma by omega epsilon is equal to 1. Again, it will save that 1.5 minute. All these 1.5 minutes that you are saving from your practice will help you out and accumulate to 10-15 minutes, which will help you out in solving 5 or 6 questions more. That will bring the change in your rank. Got it? That will bring the change. This small 30 seconds, 1 minute that you are saving here because of your practice will bring a lot of change in the exam. I hope you got the logic. Next, try to solve this question here. Skin depth at a frequency of 2 gigahertz for a good conductor with conductivity 4.55 into 10 power 7 Simon per meter. The skin depth, the penetration depth is 1.5 micrometer. The skin depth in micrometer at frequency 8 gigahertz and 18 gigahertz is find out. You know delta is 1 by alpha. Under root of 2 by omega mu sigma. Under root of 2 by 2 pi of mu sigma. Delta is 1 by under root of pi of mu sigma plus delta is proportional to 1 by under root f. This we know. That's why at higher frequencies The delta value is very less, we call it as skin depth. At lower frequencies, delta is more, we call it as penetration depth. Or in another words, low frequency waves will penetrate more into the conductor and travel, and high frequency waves will restrict themselves to the skin of the conductor. So now you tell me. At 2 gigahertz, the value is 1.5 micrometer. What is the value at 8 and 18? SDR. Yes. Try to solve. Now if you see here, the frequency here is 8 gigahertz. How many times it is greater? It is greater by a factor of 4 times. You know, delta is proportional to 1 by under root f. How many times? 1 by under root 4 is proportional to 1 by 2. It will become half when compared to the previous value. Half of 1.5 micrometer, 0.75. 0.75 micrometer. Now if you compare these two, from 2 to 18, how many times it is increased? 9 times. It is increased by a factor of 9 times. Delta is proportional to 1 by under root 9, proportional to 1 by 3, 1 by third of the previous value, 1 by third of this value, 1.5 by 3, 0.5 micrometer. So answer is 0.75 and 0.5. 0.75 and 0.5. Option B is the answer. Is it clear? Yes. Try to solve this question. It's a PYQ, previous year question paper. Any doubts so far? Yes, dear. Try to solve this. Okay, Vibhati, come on, try to solve this question 19. Question number 19. Try to solve question number 19. Electric and magnetic fields. Electric and magnetic fields of a EM wave frequency 14 gigahertz in a homogeneous medium of relative permittivity epsilon r, relative permeability mu r is equal to 1, is given by E is equal to, given frequency is 14 gigahertz, it's a TEM wave. E value is given by magnitude EP into e power j of omega t minus 280 pi y. Beta means 280 pi now. Into AZ volt per meter, and H is 3 times e power j of omega t minus 280 pi y. AX ampere per meter. Assuming the speed of light in free space is 3 into 10 power 8 meter per second. Intrinsic impedance is 120 pi. He's just trying to extend the question, that's it. We all know that the speed of light in free space is 3 into 10 power 8. We all know intrinsic impedance of free space is 120 pi. He's just trying to extend the length of the question, that's it. The relative permittivity epsilon r we need to find. And also electric field amplitude. What is the electric field amplitude here? EP. You need to find EP. These two things we need to find. Try to find and tell me the answer here. So what's the answer? Yes, small logic is there. What do you know? The ratio of amplitude of electric field to the amplitude of magnetic field at any point will give you intrinsic impedance. Am I right? What is intrinsic impedance? Under root of mu by epsilon. How much it is? 120 pi into under root of mu r by epsilon r. This small logic, we can find the answer. Now you try. Now you try. Magnitude of electric field to the magnitude of magnetic field. Magnitude of electric field, EP, by magnitude of magnetic field, 3. EP by 3 is equal to 120 pi into under root of mu r is 1. Under root of 1 by epsilon r we don't know. So, by comparing we can write EP by 3 is 120 pi by under root epsilon r. But if you compare these two equations, what do you get? EP is 120 pi. You will get many options, but you may get many options, but you follow trial and error here. EP is 120 pi. Epsilon r is 9. If you substitute EP is 120 pi and here epsilon r is 9, this equation will be satisfied. There are other combinations also it will satisfy, but it is not in the given options. 120 pi and 9. Epsilon r is 9 and EP is 120 pi. Epsilon r is 9 and EP is 120 pi. Option D is the answer. Important model here. It looks very easy, but at times it is very confusing. So you should be very careful, okay? Next. A similar model of a problem, try to solve this here. A similar model of a problem, try to solve this. Bhupati, is it clear? Bhupati, try out. Others try out. Consider two fields. Again, electric field, magnetic field, both are given. As I told you, similar to the previous question model, E is 120 pi cos of 10 power 60, 10 power 6 pi t minus beta x AY volt per meter. H is A times cos of 10 power 6 pi t minus beta x AZ ampere per meter. Very clearly, the wave is propagating in the positive x direction with electric field along y direction and magnetic field along z direction. When you see this equation, Bhupati, listen carefully. When you see this equation, you must be able to imagine the wave. What I am trying to do here, just by seeing equation, I told you the wave is propagating in x direction. I am imagining that the wave is propagating in x direction with electric field along y direction and magnetic field along z direction. Such imagination you should get. That's why the first 2 or 3 hours of our wave propagation series was on this concept. If you see this just like an equation, wave propagation will be very, very difficult for you. But the moment when you see this equation, you can imagine the wave, then wave propagation is very simple. So let us check out. Already, and not only that, it is said that it is linear, homogeneous, lossless medium. Epsilon r value is given as 8 and mu r value is given as 2. Bhupati, you need to note down. Epsilon r is 8 and mu r is 2. Do not neglect. That's the reason you got wrong answer, because you have neglected that data, that epsilon r is 8 and mu r is 2. For any given medium, magnitude of E to magnitude of H is eta. 120 pi by A, magnitude of E is 120 pi by A is eta. What you have done, Bhupati, is you took it as eta naught. So you are thinking that A is 1, which is wrong. Got it? What is eta? 120 pi into under root of mu r by epsilon r. Implies 120 pi by A is equal to 120 pi into under root of mu r by epsilon r is under root of 2 by 8, 1 by under root 4, which is 1 by 2. By 2. 120 pi into 1 by 2. From this, A is 2. Got it? Small logic, that's it. I know where you went wrong. Yes. A is 2 means either C or D must be your answer. So try to solve for beta now. Beta is omega into under root of mu epsilon. Omega value is given as, from this omega is 10 power 6 pi. Omega from the given data is 10 power 6 pi. Okay. From the given data, omega is 10 power 6 pi. 10 power 6 into pi, under root of mu naught epsilon naught into under root of mu r epsilon r. This is 10 power 6 into pi, under root of mu naught epsilon naught is 1 by c. 1 by c is 3 into 10 power 8. Under root of mu r epsilon r, under root of 8 into 2, 16, under root 16, 4. Clear? This is 4 pi by 300. Solve it and tell me. .042 it must be approximately. You also please solve it on your own and confirm. Is that clear? Next. Question number 21. Very important model. Do it very carefully, dear. Do it very carefully. Very important model. For sea water, sigma conductivity is 5 mho per meter. Epsilon r is 80. What is the distance for which radio signal can be transmitted with 90% attenuation? 90% attenuation means how much is transmission? Only 10% transmission. 10% transmission means how much is E value? 0.1 of E naught. 10% of its initial value. That's the logic. You should be able to write this. By reading this, if you are able to write this, then yes, you are on track. Otherwise, difficult. Frequency given is 25 kilohertz. What is asking us to find? What is the distance? The radio wave can be transmitted with 90% attenuation. You want distance value. How to find? How to find the distance value? How to find the distance value? Wave is sigma is given, means it is getting attenuated. E is equal to E naught into e power minus alpha z distance into e power j of omega t minus beta z, some direction ax. This is phase component, as you know. discussed so many times now. You need not consider this for the amplitude variations. E. Now this is important. 90% attenuation means only 10% transmitted. E transmitted is only 0.1 of E naught. If you are not able to write this, then it will become very difficult. 0.1 of E naught is E naught times of E power minus alpha z. Implies 0.1, E naught and E naught get cancelled. 0.1 is E power minus alpha z. 10 is E power alpha z. Alpha z is ln of 10. Alpha z is ln of 10. What is ln of 10? Substitute and tell me the answer. Ln of 10. Calculate and tell me, dear. .302, am I right? Yeah. Z is, I want Z value, distance. 2.302 by alpha. Now if you want to find this Z value, if you are able to find alpha, your answer is done. But the trick lies in how to find this alpha. Now, to find alpha, alpha value is sigma by 2 into under root of mu by epsilon formula. At the start of the class I had given you this formula, no? This for good dielectric. Alpha value is under root of omega mu sigma by 2. This for good conductor. I have this doubt now. Which formula shall I use? Shall I use this or this? Tell me. Which formula shall I use now? Because of this ambiguity, because of this logic, this model of a problem is very important. Otherwise, it's a simple problem only. Which one shall I use now? Simple logic. If you want to know which one you need to use, we need to understand first whether it is a good dielectric or good conductor. Then only you can use the formula. How to understand whether it is a good conductor or good dielectric? Find sigma by omega epsilon. Last tangent. Sigma 5 mho per meter. Omega 2 pi f. Epsilon naught into epsilon r. 5 by 2 pi. Frequency 25 kilohertz. 25 into 10 power 3. Epsilon naught 10 power minus 9 by 36 pi. Epsilon r 80. Solve this, dear. Sigma by omega epsilon. If sigma by omega epsilon is greater than 100, good conductor. Less than 1 by 100, 0.01. Less than 0.01, good dielectric. Basing on this value, you will choose this formula. Got the logic? So solve this. Pi get cancelled. 18 times. 18 5 is 90 by 25 into 80 into 10 power minus 6. This is moving up 9 into 10 power 6 by 200. 9 into 10 power 4 by 2. 4.5 into 10 power 4. 45,000. Sigma by omega epsilon. What you got is 45,000. But you know that. But we know that If sigma by omega epsilon is greater than 100, it's a good conductor. Less than 1 by 100, good dielectric. Sigma by omega epsilon is greater than 100, good conductor. Sigma by omega epsilon less than 1 by 100 or less than 0.01, that's a good dielectric. Very clearly, it's a good conductor concept. So you need not use this formula, but you'll use this formula. Find alpha value. Therefore, alpha is equal to under root of 2 pi f into mu is mu naught mu r sigma by 2. That implies alpha is under root of pi into f is 25 kilohertz, 25 into 10 power 3 mu naught 4 pi into 10 power minus 7 mu r. Is mu r given? I don't think so. No mu r value 1. Sigma into 5. Yes. Everyone find out alpha value and tell me. Find the alpha value and tell me. Fast dear. Fast. Find the alpha value and tell me, dear. How much is the alpha value? Solve that under root and tell me. .7024. Solving this, you'll get 0.7024. Done. Just substitute here, you'll get the value of Z. Z is 2.302 by 0.7024. 3.27 meter. Option B is the answer. Is that clear? Very important model, dear. Very important model. Because you should have lot of presence of mind to solve this. Lot many concepts are there here. This is one concept, this formula. This is one concept, writing 0.1 E naught. This is one concept, finding whether it is good conductor or good dielectric. This is one concept, choosing the formula. Then of course mathematical substitutions. So many things are combined in one question. This model is very important. It's a practice problem. So far did not appeared. This type of question did not appear so far in any GATE exam. Chances are very high for 2022. Clear? Not the same question, but the model. Model is very important. Okay? One more question. Like it seems like it's a lot of time that we have started now. After this question, what we do is, in the next session, we will deal pointing theorem. Otherwise, the time will be extended. Okay. Next session, we will do pointing theorem problems and polarization problems. With this, practice problems on wave propagation will be done. This is the last question. After this, I will not start pointing theorem now, but rather I will start the pointing theorem in the next class. Then we will do problems on it, polarization and problems. Two concepts in single class. Okay. This is very simple actually. An EM wave is incident on a conducting medium. Then the depth of penetration of the wave delta is asking. When it has got 2 pi radial of phase change over 1 meter. Phase change over 1 meter is given by beta. How much is beta given? 2 pi radian per meter. Given data is beta is 2 pi radian per meter, and it is given that it is a conducting medium. Already this kind of logic we had used once. In a conducting medium, alpha is equal to beta. And we know delta is 1 by alpha. Because it is a good conductor, it is again 1 by beta also. Therefore, delta is 1 by 2 pi. 1 by 2 pi distance. So pi is 3.14. 1 by 2 into 3.14. This is 0.159. 0.159. 0.159 meter. 0.159 meter. Option B is the answer. Is it clear? So pointing theorem will start in the next class, okay? It's pointing theorem and also wave polarization. Both are very, very important concepts. Some beautiful problems are in this particular topics also. Good theory concept plus good amount of questions, good logical questions will be there in pointing theorem and wave polarization. Both are equally important for examination. We'll deal in the next class. Clear, dear? Unacademy offers 2 paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you'll get all these features of Plus subscription. Along with that, you get a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study materials or specialized notes, personalized test analysis to understand where you are very strong and where you are very weak so that you can improve on your weakness, study booster sessions or workshops and customized study planner. All this in Iconic subscription. Whether you're going for a Plus subscription or an Iconic subscription, I recommend you to go for a no-cost EMI, where total cost will be divided by number of months without any extra charge, very much suitable for students. And not only that, we not only do not charge anything extra, but also you can use my code GCR10 in both Plus and Iconic subscription to get extra 10% off. And using Iconic subscription, you'll get 1:1 mentoring, increasing your chance of getting a top rank. And if you are talented and if you want to showcase your talent, you can use the Combat as a platform. Unacademy Combat is a unique platform where you can showcase your talent and also get the rewards. Unacademy Combat is a live quiz competition where 20 questions will be asked, 60 minutes will be given. These questions are designed by India's topmost faculty. Thereby, it ensures that they are of top quality. The next combat is on this Sunday, January 30 at 11 a.m. Separate paper will be designed for mechanical, civil, electrical, EC and CSIT. Those who top this particular combat and those who perform in this combat, we are ready to give away scholarship worth of 4 crores. Not only that, the good thing is 100 lucky participants will also stand a chance to win all these prizes. And one more good thing is there is no fees for this. There is no fee to join the combat. You can join for free. Enrollment is free. Just use my code GCR10. That's it. And when all this January, Unacademy has conducted All India mock test. And this Sunday, January 30, is the last chance for you people. The all GATE 2022 aspirants is a golden chance to know exactly where you stand in preparation. All India terms. When you compare with the other people, your other GATE aspirants. So you can also know where you stand And this is also useful for GATE 2023 people who are preparing for GATE 2023 to wait to start. Because you now almost you people are starting now. So you'll understand exactly what is your level of preparation so that you can achieve your target in GATE 2023. And the good thing is here also there is no enrollment fees. Enrollment fees is free. You can just use my code GCR10 and join the All India mock test. All the best dear for this. And the special classes includes interactive live classes, polls for the learners, raise a hand option, and you never miss a class once the notification is on. And you can download the lecture notes once the class is done. You can access it anytime and anywhere. This is Unacademy Ask a Doubt feature dear. Unacademy has recently introduced Ask a Doubt feature where you can ask unlimited number of doubts and get the solution in preferred language. It is very, very easy. Just a click and crop method. Very easy method to upload your doubt also. So remember dear, we are here to clear your doubts. Get your doubts clarified by India's top faculty. These are the new batches dear. Where GATE 2024 for ECE. You can see almost all the top faculty of India are here. We are ready to help you out. This is Ascent GATE 2024 for electrical. You can see all the electrical top faculty are here, including the legendary KM Rao sir. Ascent GATE 2024 for ECE. SPAR GATE 2023 for electrical. SPAR GATE 2023 for ECE. Evolve GATE 2023 for ECE. Evolve GATE 2023 for electrical. All this started yesterday, 27th of January. And these are all the new batches. Each one of them started yesterday, 27th of January. For each of them, you can use my code GCR10 to avail extra 10% off. All the best, dear. And a very big thank you for joining this session. And also, very big thank you from Unacademy. Very big thank you from the GATE Conqueror team. Very big thank you from a leader, KM Rao sir. Very big thank you from myself. Thank you and have a very good day.